In this video, I'm going to talk about how frequency and intensity of a radiation affect the photoelectric effect. So effects of frequency and intensity on photoelectric emission. Okay, let's talk about frequency and intensity. We have already discussed about frequency. Frequency F, it is related to the energy of a photon. Energy of a photon. We know the relationship, right? E is equal to hf. E and F are directly proportional. To increase or decrease the energy, just adjust the frequency. Now, what about intensity? Intensity, I, it is related to the number of photons emitted in a particular time. Let's say we have an infrared source. So this is an infrared source, IR source. So it emits photons with a particular energy. How do you find the energy of this photon? E equals hf, right? Where f is the frequency of the radiation. Okay, now to increase the frequency, I'm replacing IR source with a visible source, let's say a red light source. Okay, so it emits photons with a much higher energy compared to infrared source because the frequency of red light is higher than that of infrared. Now, if you replace red light with, let's say, green light, yeah, again, the frequency has increased. So energy has increased. So the type of electromagnetic radiation depends on the frequency of that radiation. So by changing the frequency, you are changing the type of radiation, type of electromagnetic radiation, type of electromagnetic wave. In an electromagnetic spectrum, radio waves have the lowest frequency and gamma rays have the highest frequency. So radio waves have lowest energy and gamma rays have highest energy. What about intensity of a radiation? Intensity. Let's take a red light source. Let's say it emits 5 photons in 1 second, just a random number, 5 photons in 1 second. So it has a particular intensity. You are increasing the brightness of this red light. By increasing brightness, you are effectively increasing the intensity of the radiation. That means this source now emits more number of photons in the same time period. Let's say 10 photons. Now it's 10 photons per second. In this case, you are not changing the energy of a photon. All these photons will have the same energy. They have the same energy value, right? You're not changing the energy of the photon. You're just increasing the number of photons. But by changing the frequency, you are not changing the number of photons, but you are changing the energy of a photon. So that's the difference between frequency and intensity. Now let's see how frequency and intensity affect. Let's use the same photocell. I'm using sodium metal as the cathode. Sodium metal. So we have an emitter connected in the circuit. Anode is connected to the positive terminal of the battery. Cathode is connected to the negative terminal of the battery. Keep this in mind. If electrons are coming out of the sodium metal, it will get attracted by the anode, and ammeter shows a non-zero reading because these electrons would be flowing through the circuit. There'll be current in the circuit. So let's analyze 3 graphs. The first one, current versus frequency graph. So I have current I on the y-axis, frequency on the x-axis. So in this case, we are keeping the intensity at a constant value. So we are taking different electromagnetic sources. Yeah, so this is in the order of increasing frequency. In the previous video, we have discussed about threshold frequency. That is a minimum frequency required for photoelectric emission, right? So let's say this is our F0 threshold frequency. Below threshold frequency, there will be no photoelectric effect. Up to this point, there will be no current in the circuit because there is no photoelectric emission, because we are using electromagnetic radiation with frequency less than threshold frequency. If you keep on increasing the frequency, you can see current. That's the first graph. This means below threshold frequency, there is no photoelectric emission. there is no current in the circuit, right? Below F0, there is no current. Now, above threshold frequency, you can see a steady current in this region. So frequency is increasing. Above threshold frequency, you can see a steady current, right? There is a particular value for the current. So steady current above the threshold frequency. So that's the effect of frequency on photoelectric effect. From the next two graphs, we're going to find the effect of intensity on photoelectric emission below the threshold frequency and above the threshold frequency. Okay, in the second case, we're going to use a radiation that emits a particular frequency, but that frequency is below the threshold frequency. For example, we are using sodium metal, right? Threshold frequency of sodium metal is 5.51 times 10 to the power of 14 hertz. Let's say the frequency of the red light that we are using is 4.5 times 10 to the power of 14 hertz. So we have a photocell, and we are exposing the sodium metal to a red light source that emits photons with frequency 4.5 times 10 to the power of 14 hertz. Oh, the radiation that we are using has frequency less than threshold frequency. So there will be no photoelectric effect, right? If there is no photoelectric effect, there is no current in the circuit. So again, on y-axis we have current, I. On x-axis we have intensity. But we are using radiation that has frequency less than threshold frequency, so there is no current. No matter how intense the radiation is, there will be no photoelectric emission. So there is no current. You can see the current is zero. You are increasing the intensity, but current is zero, right? So this is the second graph. So in the third case, we are using again constant frequency, but this time greater than or equal to the threshold frequency. So we know the threshold frequencies, we are using sodium, so threshold frequency is 5.51 times 10 to the power of 14 hertz. Let's say we are using an electromagnetic source that emits a radiation with frequency 6 times 10 to the power of 14 hertz. So the frequency is greater than the threshold frequency. So there will be photoelectric emission. Now we are increasing the intensity. On y-axis we have current, I, and on x-axis we have intensity. We are using a radiation that has frequency greater than threshold frequency. Now if you increase the intensity, the current will increase. You can see a steady increase in the current. So this graph is about the relationship between current and intensity for an electromagnetic radiation that has frequency greater than the threshold frequency. So this graph is the relationship between current and intensity, but we are using an electromagnetic radiation that has frequency less than threshold frequency. No matter how intense the radiation is, there will be no photoelectric effect. So there will be no current in the circuit. And let's analyze this table. So we are changing the frequency here by changing the source. We are using red light, orange light, yellow, green, blue, violet, near UV, deep UV. So we are changing the frequency. So in this case, threshold frequency is around 5.49 times 10 to the power of 14 hertz. When you use a red light, its frequency is only 4.28 times 10 to the power of 14 hertz. That number is less than the threshold frequency. So there is no emission. Same for orange, its frequency is again less than the threshold frequency. So again, no emission. Same for yellow, only 5.20 times 10 to the power of 14. So no emission. But if you're using green light's frequency matches with the threshold value, right? So yeah, we have photoelectric emission here. If you're using green light, electrons are coming out of the metal, but they don't have enough kinetic energy to jump out of the metal. So there is photoelectric effect, but kinetic energy is almost zero. But if you use blue light, the frequency is greater than threshold frequency, so there is photoelectric effect. Same for violet, same for UV, near and deep, both of them. Yeah, there is photoelectric emission because their frequency values are greater than the threshold frequency. In the second table, we are using an electromagnetic radiation that has frequency greater than the threshold frequency. Let's say blue light. When you're using blue light, there is photoelectric emission because its frequency 6.88 times 10 to the power 14. That is greater than the threshold frequency, which is 5.49 times 10 to the power 14. So we're using blue light. Okay, so this is blue light. Source is emitting photons. These photons have enough energy to kick the electrons out of the sodium metal. Now let's increase the intensity of this blue light, or let's increase the brightness of this blue light. Increasing intensity means the source is now emitting more photons per second. So intensity is 1 watt per meter square. That means the number of photons emitted per second is 2.75 times 10 to the power 15. Current is 2 microamps. Maximum kinetic energy is 0.43. Now you're increasing the intensity. Intensity is becoming double, so it's emitting double the number of photons. So 5.5 times 10 to the power 15. That will double the current flowing through the circuit, 4 microamps. But kinetic energy, maximum kinetic energy remains the same. Again, you are increasing the intensity, number of photons per second, it's increasing, photocurrent is increasing, maximum kinetic energy remains the same. So increasing the intensity does not change the maximum kinetic energy. Maximum kinetic energy depends only on the frequency. I'll tell you why in the next video when we learn the equation for photoelectric effect. Yeah. So in this case, you are increasing the intensity, current is also increasing, right? So that is this graph. You are using a radiation that has frequency greater than threshold frequency. By increasing the intensity, you are increasing the current flowing through the circuit.